Okay, dual credit video, chapter 2, part 1, frames of reference. So, frame of reference is just how motion is observed. And an example of this was given in your text, which is pretty good. This person on a train is walking 5 kilometers per hour this way. The train's moving 80 kilometers per hour with respect to the ground. So, the person's walking speed with respect to the ground is additive, 85 kilometers per hour. So it's how it's observed, because people on the train observe him walking only 5 kilometers per hour. But if there was somebody out here on the ground watching the whole thing happening, he would appear to be moving 85 kilometers per hour. So frame of reference is how motion is observed. So a lot of times we talk about different frames of reference at times. Now, how we determine position is based off the coordinate axis that you had in math, and we keep the standard XY designation with up and to the right positive and left and down negative. What you'll find is that we can manipulate this in different ways and different ways to solve problems. We can choose positive and negative, which will help us if we want to avoid these pesky negative numbers. But as of right now, we will consider right positive, up positive, and down and left negative. Terms: position, where the object is located. Distance, how far the object has traveled. It's a scalar. Distance is always positive, and there's never a direction. I'm a step too far. Displacement is the change in position. It's where the object starts to where it stops. This is a vector. There is a direction involved, which means there can be positive or negative displacement. Distance always positive. Displacement can be positive or negative. So, for example, here, this person has walked 70 meters up, then goes back 30. Okay? Let's talk about distance. How far traveled? You traveled 70 and then 30. Your distance was 100 meters. Your displacement from where you start to where you finished is 40. So your displacement's 40 meters. And since it's going to the right, we call it positive. Again, positive and negative just based on direction. But distance and displacement, there is a difference. So let's look at another situation here. We have displacement, meaning x2 minus x1, our final position minus initial position. So for this case here, all right, our final position is 30. Our initial is 10. Our displacement is 20 meters. And it's positive. Here, we're starting here and finishing here. So 10 minus 30 equals negative 20 meters. Our distances are the same, 20 meters. It's just if we're going one direction, it's considered negative. And if we go the other direction, it's considered positive. Again, positive and negative just mean direction.